Okay, we're nearly the bottom of the hour and we'll be bringing up our next speaker shortly. Again, as I mentioned earlier, we have extended the cake submission deadline until 8 a.m. tomorrow morning. The judges will then diligently make the judging in time for the presentation of the winners over the lunch hour tomorrow. So please consider baking your cookies and cakes. There are valuable prizes to be won for the best entries. And better yet, you get to eat them afterwards. So with that, our next presentation coming up here is going to, again, sort of look at that theme of infrastructure from a different perspective. We're going to be moving into a presentation on seamless outdoor and indoor mapping and 3D imagery. Our speaker on this topic is Myles Sutherland from GeoCam. And whenever you're ready, Myles, you can go ahead and take it away.
Awesome. Thank you so much. Pretty excited to be here on GIS Day. I got my special map shirt out and I already ate my cookies. So I've got my photos submitted. So we'll see how those go. I'm just going to share my screen here quickly. Awesome. So really excited to share a little bit about the work that we've been up to at GeoCam. Just as background, we're a small startup. We've been around for a few years. We're based out of Manhattan Beach in Los Angeles. So we're local to you all. You know, just in background, some of our team come out of the computer science and machine learning and image processing background. I specifically come out of the sort of GIS, geography, geospatial industry, having worked at a few different of the larger GPS and GIS companies in the industry over the years. And so a lot of what you sort of see from GeoCam is about what we think is a really interesting take on improving the way that we collect data. And we think of it from a visual standpoint. So using photogrammetric techniques, using imagery to create high definition geospatial data. So the way that we've been going about this challenge, which has been going on for decades and decades, creating data is always a huge challenge. Maintaining it is an even bigger one in some cases. We've kind of come up from a perspective of like, how do we simplify this process by using really low cost cameras, using photogrammetric techniques that I mentioned before that enable us to create data. And I use the word seamless in the sort of title because we think about it from an aerial perspective, a ground or street perspective, and an indoors, including some underground, which maybe we'll talk about at the end. And so, in our sort of background and history of working in the industry, there's some complexity to sourcing multiple data sets that come from different types of sensor systems, come with different levels of accuracy, and come from different perspectives. You've got aerial, you've got street collection, LiDAR systems, GPS field sort of thing. So we build these tiny little cameras, we build image processing, and that image processing enables us to create traditional kind of orthomosaics, digital surface models, but we can also produce some of the newer data sets that are becoming very, very popular, like 3D textured meshes to use in 3D scenes. And we do this from the aerial, the street, and even the indoors. So I'm just going to touch on each of those, just to give a little bit of context of what we've been up to. So let's just start with some of the aerial side of things. Our kind of vision for the business was, could we make a tiny little camera that could be used anywhere in the world? Really simply on any type of platform, any type of plane, starting with the small fixed light aircraft. And could we do it in a way that we could potentially ship a device to somebody on another continent and they could quickly go lease or use a plane themselves? And so that's the path and the journey that we've been on. We've been iterating and building these things in the backyard here in Los Angeles. Some of our team is also based down in New Zealand. I myself have been here for about 15 years and this is my home and this is where we run the business from. And so we create these tiny little cameras. And we generate these 3D point clouds, digital kind of surface representations, and 3D meshes. On the screen here, this is an example of a sort of city scale point cloud that we can create these days from such a tiny camera. This is a 5 cm resolution point cloud. It's published as a scene layer package. Works really nicely in Esri's ArcGIS online web viewers. And obviously that technology has evolved a massive amount over the years since we started this, and it makes everything a lot easier for us to be able to publish and make this sort of data consumable. You know, 5 years ago, 10 years ago, this was this pretty tough thing to be able to work from. A little bit of a better view into that. And then I'll just touch on this. This is the city of San Jose, some of the data that we've collected up there. You'll notice there's a whole bunch of poles that are included in this scene. We also have a reasonably unique capability, is that we can map objects out of the raw photos that are collected with the camera. And everything that we do is 3D. So you get an X, Y, and Z position to create, you know, points, lines, polygons, or multi-patches from the raw photos, in addition to these digital surface representations like the 3D mesh you see there. And we operate the business as a service today. So we're actually out flying, collecting the data, processing it, and delivering data. Okay, so that's just from the aerial perspective. Let's look at what this looks like from the ground perspective. The same sort of capability. We built a very similar type of camera. This is a 360 version. It's gotten a lot smaller over the years. Some of the team on the call here have seen the previous versions of it when it was a backpack, and before that it was a tripod system that went on top of a vehicle. We've slowly been miniaturizing the devices, so it's A, easier for us to build them, and B, it's just easier for other folk to start using them. And that's kind of the goal for our business, is to enable anybody to take one of these cameras and deploy them really rapidly on their own vehicles, whether it's a truck, car, ATV, bike, or walking around with them. Today we drive them around, do a lot of collections, driving entire cities, focusing on fiber networks or electric utility network areas. We also use them on road engineering projects, where we're looking at the surface conditions of the road to support the transportation kind of engineering practices and processes. These devices, we collect a ton of imagery, not too dissimilar to what you may have seen from laser scanning systems. The difference being it's just all photos and GPS. So, you know, these things can collect upwards of 1 terabyte of imagery a day. This gets processed in some, you know, reasonable compute systems in the cloud or locally. And the end result of that is an updated street view. And it's a pretty interesting street view because it gives you not just the ability to view the imagery, we can also go create GIS-ready vector data into geodatabases and feature services. And then we can also get into things like this, the 3D reconstruction. So we will generate, when needed, 3D point clouds from the photogrammetric techniques, and those are seamless side by side with the imagery and any of the GIS data that's been created. Same thing happens with the 3D meshes. This is definitely an evolving area. You know, creating the 3D meshes from the street perspective is a little different to when you do it from an aerial camera, an aerial perspective, a little different for what you may have seen from the drones and UAS-based systems. The lighting conditions can be a lot trickier. You know, flying lighting is an issue, but when it comes to driving, you're going in and under different tunnels and bridges, you're dealing with vegetation, urban canyon, and then of course, just like the aerial side of things, we deal a lot with, you know, sunrise and sunset. So we do a lot of things in the camera to sort of mitigate for this, that makes this sort of 3D mesh generation a little bit easier. And you'll see this area evolve from us rapidly over the next year or so. So we continue to invest in producing much higher quality 3D mesh representations. Okay, so let's shift a little bit to some of the indoor side of things, because it's sort of the newest area. And again, this gets a little trickier. So couple of years ago, we sort of had the vision that this could also work indoors. When you don't have GPS, it gets a little trickier. A lot of existing systems today often will use an odometer, or they will use high-end IMU, or in the LiDAR space, there's been some big advances around SLAM-based techniques using LiDAR ranging measurements. In our case, we're again just using the same photogrammetric techniques, going in and being able to process the imagery to determine the position and orientation of the camera in 3D space. And once you're able to lock that off, that gives us this kind of foundational, we call it the pose, but it's kind of like the GPS equivalent locations that you get outdoors. You have the equivalent indoors. On the left side of this viewer, you can see a whole bunch of arrows that show kind of the direction of travel that the camera, in this case, had gone through this bank. And then again, we'll produce a viewer of the imagery. You can also map out the objects. It can be simple GIS features, or it can be more complex CAD representations and complex geometries. 3D meshes working seamlessly outdoors and indoors. I just use this one because it's one of our team's kind of residents. It's a nice little demo. This scales up obviously to any size building. We can now do this in million square foot buildings, but this is a cool look at some data that was collected on a residential property outdoors and indoors. I just sliced the roof off so you can kind of see into the garage and see into the building itself. So this, this is a complex area indoors because it's also three-dimensional. So we're dealing with the camera having to go not only from outside to indoors into a ground level floor, you're now dealing with staircases and multiple floors. And so we're able to actually get this image processing to work seamlessly across all the different floors. So our team that use the camera, they make a little bit of a plan of what they're going to do. They can come into your facility and they're very, very quick. So there's less of an impact on the business. We don't require turning lights on necessarily, unless it's super pitch black. We don't have to move people out of the space, people in the space. We will blur faces, blur number plates and the outdoor side of things out of the imagery. But this just sort of shows you the pose of what's happening from this image processing technique. And we'll produce CAD data you're all familiar with. And more recently, we've been doing really detailed mechanical engineering plumbing spaces. This is a space that's actually a chocolate factory. It was all stainless steel. This is a real challenge for a laser scanner. We get a lot of reflection off the stainless steel. Sometimes it requires them to put a cheesecloth over the pipes or maybe to powder coat them in some way. It's pretty complex. We're able to take the camera up the staircase you can see in green on the right, process all this data, produce, this is a Revit model that was produced in Autodesk Revit software, and then it's brought back into a viewer like ArcGIS's viewer with its building scene layer capabilities, which is a really exciting area that's been developing really, really fast as well, which is pretty well aligned to the areas that we've been investing in. Awesome. So let's move through this a little quickly. So maybe there's some questions and things that we can chat about at the end. We've been starting to do this in underground. It's kind of the fourth area that we're starting to work on, is helping map out these underground environments. And our contribution to it is about helping pick up paint markings and things that are happening on the road. So you get like this kind of representation of not just the survey points, but you're getting all the context of what was done, and all the markings and everything that was put down as part of a underground locating process. And then in the, I call them person holes. In the person holes, you can push the camera down them and we can 3D reconstruct them and create these meshes. And this is another place that this sort of technology is getting very powerful. With the advent of a lot of augmented reality, you're starting to see some companies building really cool augmented reality applications that can use this data and help people see and visualize what has previously been kind of like a little, sort of muddy to us. Where are the pipes underground? What do the people holes look like? Now with some of the augmented reality apps coming out, plus this sort of data, it's really easy for people doing quite complex field work to be able to get some insight to what's under the ground before they do their work. And we do a little bit of disaster response. So we take the same sort of technology and we deploy it inside of different types of events that have occurred. This can be fires, it could be hurricanes, tornadoes. This is more about speed and generating data. Oops. Sorry about that. This is more about the speed of generating data and getting it into the hands of decision makers really, really rapidly. Yeah, so I just wanted to sort of conclude and just give you a little bit of insight to what we've been up to at GeoCam. You know, we're based here in the backyard, and you know, we've been sort of slowly iterating away at the technology, and hopefully you'll see a lot more from us as we start to scale up the business and grow the team here as well.
All right, Myles. Well, thank you for a very interesting presentation and some of the really cool imagery and visualizations in different spaces than a lot of us who traditionally do GIS are thinking about or just starting to think about. So again, if you have questions for Myles, you can pop them in the Q&A, but I have some that have already come into me. So first question for you, Myles, is does your system or tools automatically identify assets and extract them into GIS feature layers of some sort?
Yeah, that's a great question. So when we started on this, we actually did start working a little bit on the object detection, the sort of segmentation and classification from machine learning. We actually sort of pressed pause on that to focus more on how to get really accurate position and orientation of the images, knowing that longer term, the machine learning industry was going to evolve pretty rapidly. So more recently, we've started to do that. Most of the projects we do still involve a blend of machine learning for the extractions and some sort of QA, QC work that we do. And it varies, right? So for us right now, there's some really quite simple things like detecting street signs or street lights. And there's been some other companies who have innovated a lot in that area around the machine learning. Other places it's really complex, right? So for example, electric utility pole models, you know, getting into structural engineering, that's still evolving. That's not something that we've been doing with any form of machine learning. That's still done manually by clicking in the photos. And then in the indoors, we've been testing out and working on things related to the fire life safety assets, because that's a class of asset that is common across all buildings that pretty much all owners or operators really need to have a good understanding of where they're at. And so, yeah, I don't think, you know, Steve, long term, our vision is not to be the super experts on all the different types of objects that need to get extracted. There's a huge long tail to that when you start thinking about a camera that you could take in all sorts of places. You know, we've used this camera to scan logging trucks before to measure the rings in the bark on the back of trees that have been cut and felled onto a logging truck. And that's an area that there's some really specific machine learning that needs to be done, real industry specific. And so I don't see us doing that. We'll probably be more partnering and working with companies who are building their own models that are industry specific.
Very good. We have a couple questions that have come in. So first from Mike, says hello. He wonders what you might be doing with GeoBIM and syncing from between Revit and ArcGIS.
Yeah, so for us, there's two places. One is being able to create 3D geometry data that, let's say it's CAD Data or contributes to being part of a BIM-based system. That's an area that we can contribute to today. When it comes to the visualization aspects of it, that's also another area. So once that data has been created and often fused with other data sets, you know, we have the ability to visualize the BIM and CAD data. We sort of focus specifically on geospatial. So if that data is then, geospatial, we bring it back into something like an ArcGIS system, and then we can visualize it with the imagery. As it relates to the specific kind of like GeoBIM products, that's not something yet that we've had a chance to really play around with or become experts in. We still have our own challenges keeping up with all the innovations that are happening in other areas,
Sure. Yeah. Okay. And then Sebastian asks, are there any government agencies looking to use this technology, for example, in disaster relief agencies for site inspections or helping survivors of emergencies?
Yeah, there are. So the work that we've been doing over the last few years on disasters has been, I would say, more about innovating and prototyping and proving out that we can deliver data in a complex environment. And we've been doing that with local governments and insurance companies. Like we've done a little bit of work with USAA, who are investing heavily in supporting people dealing with these events, and the same with the local counties that have been impacted, whether that's Napa County or others that have been Butte County in the past that's been impacted pretty heavily. More recently, we've started working on a partnership with the Western Fire Chiefs Association. They share a sort of similar vision to us about collecting this sort of data as quickly as possible. And the goal of the partnership is to get imagery in the hands of first responders as fast as possible. Not necessarily to help solve for, putting out a fire, but it's getting damage assessments and these other bits of critical information that help with the funding process, that in turn can help people recover quicker from these events. And for me personally, that's the thing that I see going to these events. Like the quicker that we can help people get access to capital that they need to recover from these events, the quicker the community can recover itself.
Mm-hmm. Okay. And then there was a question about indoor routing. So you showed a lot of the indoor mapping capabilities. Does your data work with indoor routing applications, for example, to help somebody find a particular room where, a service or something might need to be done?
Yeah, it does actually in two ways. One is when we actually walk through the building, we focus on going into every space. So we actually get almost like a route path of where you have to go to physically go into every space. And we can turn that into a network graph, something that supports indoor routing algorithms and software really quickly. And so today we do some of that work with the ArcGIS Indoors team and the product that Esri's been building that then works with the data that we create into the ArcGIS Indoors format, both for the physical building structure and the network graph and the locations for places you want to query the route to. And we also do it in a more of a simplistic way, which is like just producing a representation of all the spaces and places that you could actually route to. So yeah, that's an evolving area along with the indoor positioning. And this may be one of the areas that gets really exciting with the visual approaches long term. We're seeing this with Apple and Google and Snapchat and others, where using these kind of augmented reality techniques, you can position yourself visually in combination with Wi-Fi and Bluetooth. And so, the routing becomes navigation, or it becomes more powerful when you have the positioning. And that's an area that we're pretty passionate about. And we think that long term will play a big role in everything that we're doing is visual positioning and routing supporting this.
Sure. Another question that came up is probably, I think, relating to some of your outdoor work, but probably indoors too. How do you work around features or assets that are hidden behind parked vehicles or other obstructions when you're collecting data?
Yeah, great question. Yeah, we make these products ourselves, so we're out there doing the work. Like we're not just sitting in the lab trying to dream something up. And so, like any good startup, our job is just to kind of learn and evolve. And one of the things that we have learned out of this process is vehicle-based systems do have occlusions because you're constrained to the road. And so there's been a couple of ways that we've thought about this problem. And one is collecting real high frame rate imagery. so that if there are parked cars, you can kind of see in between them. We'll collect data that's even, every meter or more, could be even half a meter. So it's a ton of photos, and you can often see fire hydrants and things in and around parked cars. The second is, because it's a 360 camera, if there's places we can't see something, we can rapidly go back to and collect from a footpath perspective, because the camera just goes on a pole and you can just walk around and fill in the gaps really quickly. And then, there is this idea, which I've never done, which is optimize the collection related to the street sweepers. So in some cities, the street sweepers are used more aggressively than others, and where they are, a lot of the cars are cleared off the roads. Like in the city I live in, 90% of the city are street sweepers, and over a week, they kind of clear the cars roughly. And so there is this idea to time your collection related to the street sweepers. And that becomes really useful if you're trying to optimize for doing a footpath survey and looking at not just at ADA ramps, but you're looking at faults and cracks in the footpath that might be occluded.
Okay, well, very good. So we are at 5 of the top of the hour. So I do want to thank you again for taking the time to share all this really cool stuff, indoors, outdoors, underground. I think there's a lot of opportunities as we look at sort of the other places we're going to move in GIS over the next few years, and all these tools. We will take 5 and come back at the top of the hour for our next presentation. And I think you'll all be pretty excited by this next one. I know I am. This is a student presentation, and we're not talking college students. We're talking high school students using CubeSats and data to look at issues of the homeless population in high-risk fire areas. So stay tuned for that in about 4 minutes.